In this video, we'll learn how to draw Lewis structures. Remember that covalent bonding is the sharing of electrons between two atoms. And carbon forms covalent bonds because gaining or losing electrons is too high energy. We also see covalent bonds between atoms of similar electronegativities when there's no real drive for the electrons to be on one atom over the other. We depict covalent bonds using Lewis structures. In Lewis structures, valence electrons are indicated as dots, and the bonds are indicated as lines between atoms. On the left here are the steps that you'll take to draw a Lewis structure from a formula. First, you'll determine the total number of valence electrons for all atoms in the molecule. Then you'll draw the atoms, and you'll put the atoms that form one bond, like hydrogen, around the outside edges. Then you'll add the valence electrons to each atom. And finally, you'll connect the atoms with bonds. And I say finally, but really there should be another step here that is to double check. Tally all of the bonds and valence electrons and make sure they match the total that you calculated in the beginning. Also make sure that each atom has an octet. Let's walk through an example. We'll draw the Lewis structure of CH4O. We'll start by determining the total number of valence electrons. And this is the number of each kind of atom in the molecule times the valency of that atom. Okay, we have one carbon, and carbon has a valency of 4. We have 4 hydrogens, and hydrogen has a valency of 1. And we have one oxygen with a valency of 6, for a total of 14 electrons. Next, we'll draw our atoms, and we'll put atoms that form one bond, like hydrogen, around the periphery. Okay, next we add our valence electrons. 1 electron to hydrogen, 4 to carbon, and 6 to oxygen. And then we'll connect the atoms with bonds. Okay, when we're done, we'll do a double check to make sure that all atoms, except for hydrogen, have an octet, and that we have 14 electrons in our Lewis structure. Okay, now you can try this one. Pause the video and draw the Lewis structure of CnH5. Okay, welcome back. To tackle this problem, we'll start by determining our total number of valence electrons. We have 1 carbon, which has a valency of 4, 1 nitrogen with a valency of 5, and 5 hydrogens, each with a valency of 1. This gives us a total of 14 electrons, or 7 electron pairs. Now we'll draw the atoms, and we'll be sure to draw the hydrogens around the outside edges. And then we'll give each atom its appropriate number of electrons based on its valency. Okay, next we'll add bonds between the atoms. And when we're done, we'll check that all atoms other than hydrogen have an octet. And we'll also check that we have a total of 14 electrons in our Lewis structure. And we do, so we'll end here by redrawing our structure in a clean fashion. We'll end this video by solving the question we posed at the beginning, to draw the Lewis structure of C2H6O. And first, we'll determine our total number of valence electrons. We have 2 carbons times 4 electrons is 8. 6 hydrogens times 1 electron is 6, and 1 oxygen times 6 electrons is 6, for a total of 20 electrons, or 10 electron pairs. Then we'll draw our atoms, putting carbon and oxygen in the middle and arranging the hydrogens around the edges. We add the valence electrons to each atom. And then we'll connect the atoms with bonds. When that's done, we double check our structure for octets and for the correct number of electrons, 20 in this case. So this is a good Lewis structure, but it's not the only possible Lewis structure for this formula. And you may have come up with this structure shown in blue on the bottom, and this is just as correct as the Lewis structure that I originally drew up top.